Indirect measurement's a super important application of triangle similarity and all the truths we know about it. This first example here, I'll leave my camera here for a minute and you can pause and look through it. It's a really bad picture of a pyramid, which makes it hard to understand that even though the perimeter's 3,023 feet, you divide it by 4 to get one side, but you have the one side plus you have the shadow. So what I've tried to do here is draw a comparison of the 5-foot tall person with a shadow of 7. Whoops, I even did that backwards because it'd be 5 feet tall. Shadow of 7. So let's make this shadow go out farther. Okay, compared to a height you don't know for a pyramid to its base plus its shadow. So there's a whole lot of math in here, but this is a fun challenge, but not where I want to spend our time. Pause it here, look through it if you want to know. We can talk about it individually, but what we want to really look at is what is indirect measurement. So proportional relationships help you find distances that cannot be measured directly. Consider like how wide is a volcano that's active. You don't want to get up close to it, but you could take specific landmarks and create the math that allows you to know the opening. So indirect measurement is any method that uses formulas, similar figures, and or proportions to measure an object. The word object is right there. Measure an object. Okay. So here's some guided examples for us to look at. The first one, let me get this here, shows a figure, triangle DBA. They're already telling you it's similar to ECA. So let's go DBA. Go up from D. DBA, ECA. So we have the small pink triangle, the larger greenish yellow one. We transfer the measurements 40 and 320. That's going to compare to here. This is supposed to be the distance across a lake that we do not know, to 482. So set it up so you put your sides that correspond together. Your 320 is to your 482. 482 is from 320 plus 162. It looks like right there. As 40 is to x. Remember, when it's the bottom part, you have to be sure and add it together. So when you cross multiply, you get 19,280 equals 320x. Divide both sides by 320, and that distance across the lake is 60.25. Another example here. Here's number 2. Michigan Avenue and Kentucky Lane are parallel streets. So let's put our little arrowheads on them. Okay, so we have 6 is to x. Those are the two bottom sides. As 4 is to 4 plus 4, 8. Cross multiply, 24 is to 4x. Divide both sides, and you get, 48. 6 times 8, 48 equals 4x. Divide both sides by 4. X is 12. For example 3, I think we're back to shadows. They want to know how tall the tree is, but there's a shadow of 2.2. These are in meters, compared to the height of the animal, which is 0.45 meters, and its shadow is 0.3. So shadow to shadow, 0.3 to 2.2, as height to height, 0.45 to x. Cross multiply, and you get 9.9 equals 0.3x. Divide both sides by 0.3. The height is 3.3 meters. Okay, you have another example. Over here, remember I told you whenever you have the connected triangles, the corresponding sides create a line. So we're missing this side here, but we know this is 5, so those are paired. We've got our big triangle, our D we don't know compared to the 5 that we do, and then we take our big triangles, 8 in the numerator, keeping everything big in the numerator, compared to the 4, cross multiply, 4D equals 40, divide both sides by 4, D equals 10. That allowed us to get this length we did not know. And the last example, given triangle ABC and DEF are similar, there's the wave that indicates similar. The lengths of the sides of ABC are 15, 17, 20. Think French fries, small, medium, large. 15, 17, 20. what is the length of the shortest side of DEF? And so the length of the largest side of DF is 28. So we can say 28 compares to 20. And here we're doing our big triangle information in the denominator, small triangle information in the numerator. So since our biggest side is 28 and our biggest side is 20, 28 and 20 are compared. On our small triangle, our smallest side was 15, and they want the smallest side of this one, that's our x. So here's all the information about the small triangle in the numerator, all the information about the large. Cross multiply, get 20x equals 420, divide both sides by 20, x equals 21. There are some examples.